In this video, we are going to discuss some numerical problems. Exercise 6.5. The enthalpy of combustion of methane, graphite and dihydrogen at 298 Kelvin are minus 890.3 kJ per mole, minus 393.5 kJ per mole, and minus 285 kJ per mole respectively. So this is the enthalpy of combustion of methane, okay, at 298 Kelvin. The enthalpy is here for methane, for graphite and for the hydrogen, okay, respectively. Enthalpy of formation of CH4 will be, okay, so from this option we have to find the correct one, okay. So these values are given, okay, so combining all these values we have to find the enthalpy of formation of CH4. So the required reaction, okay, for this one, formation of CH4, we'll write now. So please remember that this should be in 1 mole, okay. So we have to add 2 here, okay. So for this case, enthalpy of formation, we don't know this enthalpy of formation, okay, we have to find, okay. Now this combustion means heating, okay, in presence of oxygen, okay. So combustion of methane, okay, so methane is this one, okay. Let's write the reaction. CH4 gas plus oxygen gas, okay, to give, it will give carbon dioxide and water molecule, okay. So just balance this reaction. Now this will be gas, this will be liquid. Delta H for this is given already, 890.3 kilojoule per mole, okay. So we'll take this one as our equation 1, okay. Next one is graphite. So graphite is an allotrope of carbon, okay. So carbon solid plus oxygen gas, so it will simply give us carbon dioxide. Now delta H, it's already given, minus 393.5 kilojoule, minus 393.5 kilojoule per mole. We'll take this as equation 2. Next one is dihydrogen, okay, combustion of dihydrogen. Dihydrogen is H2, so this will be gas. Now oxygen gas, so it will simply give us water, okay, molecule, H2O, liquid, okay. So we just have to make this as 1 mole, so let's make this one half, okay. Now delta H will be minus 285 kilojoule per mole. Let's take this one as equation 3. So this is our required equation, okay. This is our required equation. This is our required equation, okay. Now we are going to do some arrangement, okay, from these reactions, okay, from these equations, and we have to, okay, find, okay, the required equation, okay. We have to make out the required reaction from these equations, okay. So firstly, in this required reaction, okay, what you will find is carbon and hydrogen, okay, to give CH4. So in this case, okay, if you look at equation 3, 2 hydrogen here, okay, so we need 2 moles here, 1 moles, so we'll make it into 2 moles, okay, multiplying equation 3 by 2, okay, we get, so this will become 2H2 and this will become O2 only, okay, let's write gas, this will be 2H2O liquid, okay. So even for enthalpy we will multiply it by 2. So when we multiply this by 2, what we will get is minus 571.6 kilojoule per mole, okay. Now let's take this one as equation 4. Now what we are going to do is just check equation 2. Carbon is present, okay. Now this hydrogen is there, okay, this 2 moles of hydrogen is there, okay. Now here oxygen is there, okay. So what we are going to do is we are going to combine this equation 4 and equation 2, okay. Now adding equation 2 and 4 we get, so we are going to add equation 2 and 4. So this one, C solid, carbon solid, plus this one, dihydrogen, yes, plus this oxygen, 2O2, okay, this oxygen 1 2, so 2O2, we write 2O2. Next is CO2 plus this water molecule, okay, to this one and this one, so 2H2O liquid. Now delta H will be, okay, this delta H will be this one, okay, minus 571, this one, okay, minus 571.6 plus this one, okay, since we added these two, okay. So after adding, what we are getting is minus 965.1 kilojoule per mole, okay. So let's take this as our equation 5. Now what we are going to do with equation 1 is we are going to, since this one is at the left side, we are going to, okay, make it into the right side, okay. So we are going to reverse this reaction, okay, this one, okay. So we bring this one here, we bring this CH4 here, okay. Now reversing equation 1, so what we will get is CO2 gas plus 2H2O liquid, and then this one CH4 gas plus 2O2 2O2 gas. Now if you reverse, the sign will change to positive, okay. This will become positive, okay. The enthalpy change will remain the same, only when we reverse it, okay, it will become positive. So plus 890.3 kilojoule per mole, okay. So this will become our equation 6, okay. So notice here in this reaction equation 5 and 6. Okay, now what we are going to do is we are going to add equation 5 and 6 and we will get the required equation, this equation, okay, this one. So in order to get the required equations, what we are going to do is just compare these two equations, CO2 CO2. Okay, we don't record CO2 in the main reaction, so we just cancel this, H2O H2O cancel, okay, and then O2 O2, okay, this 2O2 2O2 cancel. So what remain here is this carbon plus 2 moles of the hydrogen, and then this one. So in this case only these three reaction, okay, this three remains, okay, so these three will be the required reaction, okay. So if we add, only these three remains, okay, and this enthalpy also we are going to add, okay. So after adding this enthalpy, what we will get is and adding these two enthalpies, 961.1 kilojoule and 890.3. So our answer will be minus this one, okay, 74.81 kilojoule. If you calculate, you will get this one, okay. So this will be your answer, okay. So in this kind of questions, okay, following that Hess law, okay, these reactions, okay, actually consist of a number of steps, okay. So we just bring out those equations, okay, add them, okay, like this, okay, to get this one, okay, like this, okay, okay, and then we cancel out this oxygen, okay, okay, after adding we have just cancel out, okay, and finally we have to get the required reaction, okay. So if you get the required reaction, you just have to add these two values, okay, or two equations, and then you will get the answer, okay. So I hope this is not that confusing, okay. If you practice, you will get the idea. Now next one, 6.10, calculate, okay, I'm writing it short form. Calculate the enthalpy change on freezing of 1 mole of water at 10 degrees Celsius to ice at minus 10 degrees Celsius, okay. Delta friction is given 6.03 kilojoule, okay, per mole at 0 degrees Celsius. Cp, okay, heat capacity, okay, is given for water at liquid, okay, in liquid state, 75.3 joule per mole per Kelvin, and for solid it's given, that means ice, okay, 36.8 joule per mole per Kelvin. Now solution. Now we know that this change in enthalpy, okay, or heat, okay, it's given by this equation Q and C. So where N is the moles, okay, C is the heat capacity, and delta T is the change in temperature, okay. So in this questions, okay, it has 3 steps, okay. The first step is, it's given here, okay, 10 degrees Celsius to minus 10 degrees Celsius. Okay, firstly it will be 10 degrees Celsius to this, okay, 0, and from 0 to minus. Okay, so for 0 it's given here also, okay, the value. So let's discuss here. So this enthalpy change, okay, of this 1 mole of water, okay, from this 10 degrees Celsius to 0 degrees Celsius. Okay, let's write it. H2O liquid, okay, 10 degrees Celsius to 0 degrees Celsius, it will give you H2O liquid. So at first it is in liquid state. Okay, it's given here also. Okay, now this is the final one. Okay, this is the initial temperature. So final minus this one, we are going to get minus 10 only. Okay, so our delta T will be is equal to minus 10 only. Okay, so let's take it as delta H1 for this one, the first case. Okay, so CpH2O liquid into delta T. So this one, this value is given here. Okay, so since only 1 mole, okay, we're just going to write 1, okay, into 75.3 joule per mole per Kelvin. Okay, into change in temperature is this one, minus 10 degrees Celsius. Okay, so instead of minus 10 degrees Celsius, we are just going to write minus 10 Kelvin. Okay, so why I'm writing this 10 Kelvin, okay, instead of degrees Celsius is whenever you calculate 273 plus 10, it will give you only 373 Kelvin. Okay, if you change this degree to, so this one, it will be only 273 Kelvin. Okay, for 0. So if we minus, we are getting 10 only, 10 Kelvin. Okay, so this, okay, if you calculate like this, it will take much time. So simply, you know, right, the difference, whether you do it, you minus this one, 10 degrees Celsius, okay, 0 minus this 10, minus 10, okay, you are getting this 10 only. And if you add this value Kelvin, even that also you're getting 10 Kelvin. Okay, so no need to calculate, simply you can just write 10 Kelvin. Okay, just without wasting your time. Okay, now Kelvin we just cancel, and what we will get is minus 53 joule per mole. Okay, so let's convert it into kilojoule. So this will become minus 0.753 kilojoule per mole. Okay, we are dividing it by 1000. Okay, and bringing this kilo also. Now for the second case, okay, this conversion of 1 mole, okay, at 0 degrees Celsius, okay, it will be, this is the third step. Okay, so this is the third step at 0 degree to 0 degrees Celsius. Okay, this is the third step. Okay, so in this case it will be in liquid state. Okay, let's take it as delta H2. Okay, so in this case there is no change in temperature. Okay, and then delta fusion is given. Okay, 6.03. okay, and fusion means sorry, this will be solid. Okay, solid. Okay, at 0 degrees Celsius, okay, it was liquid here. Okay, now from liquid it will change to solid. Okay, at 0, slowly. Okay, so we just write this as solid. Okay, kilojoule mole inverse. Now we are getting the same value, this one. So let's convert it into kilojoule. So minus 6.03 kilojoule mole inverse. Next, the third one. Now H2O, this one solid. Okay, so the enthalpy change here. Okay, so it will be solid now from 0 to minus, so 0 degrees Celsius to this minus 10 degrees Celsius. Okay, so in this case from 0 to this one it will be minus. Okay, change in temperature will be minus 10 Kelvin. Okay, so instead of this degree and convert it into this one, we are just simply writing this one. So delta H3 1 into this value is given 36.8 joule. Okay, so 36.8 joule per mole per Kelvin. Okay, into this one minus 10 Kelvin. Okay, Kelvin can be cancelled, so what we are left with is minus 368 joule per mole. Okay, so if you convert into kilojoule, it will become minus 0.368 kilojoule per mole. Now from Hess law, okay, the sum of all these three steps, it will give us the enthalpy. Okay, change in enthalpy. Okay, the total enthalpy. Okay, so let's denote it by delta H total. So the first one we got this one 0.753. okay, plus this one 6.03 plus 0.368. okay, so we are just writing this kilojoule outside the bracket. Okay, so what we get here is the answer is minus 7.151 kilojoule per mole. Okay, let's discuss the next one. Enthalpy of combustion of carbon to CO2 is 39.5 kilojoule per mole. Okay, now this combustion, it will take place in presence of oxygen. Okay, this carbon is combusted to this CO2 and at 39.5 kilojoule, okay, per mole. Calculate the heat release upon formation of 35.2 gram of CO2 from carbon and dioxygen gas. Molar mass of CO2 is 44 gram per mole. Now for this one, it's given. Okay, now what we are going to do is we have to find this for this one. Okay, so combustion, let's write the reaction first. Okay, so combustion of carbon to CO2 will be C, okay, plus oxygen, this dioxygen, to give CO2 gas. Delta H, it's given minus 39.5 kilojoule per mole. Okay, so this molar mass, okay, we can get it by this carbon atomic number. So this molar mass, okay, for this carbon CO is to calculate this molar mass, okay, CO atomic weight is 12, oxygen 16, to 2. So if you calculate, you will get 44. Now in this case we are getting 1 mole, okay, 1 mole of carbon dioxide, okay. So in this case 1 mole of CO2, okay, gives 30 minus 39.5 kilojoule mole, okay, of this enthalpy change, okay, or enthalpy of combustion, okay. Now we have to find 35.2 gram of CO2, okay. So this 35.2 gram of CO2, how much, okay, enthalpy of combustion, okay, will be involved, okay, for this case. Now 1 mole of this one is equal to this one, okay. So in this 1 mole, this one is 44 gram, okay. This is in 44 gram, this carbon, okay. Now for 1 gram of this carbon dioxide, okay, it will make 1 by 44 mole, okay. So this will be is equal to 1 for 1 gram of CO2, it will be 1 by 44 mole, okay. Now for 35.2 gram of CO2, it will be 1 by 44 in, okay, to this one, 35.2 gram, okay. So cancel, you will get 0.8 mole, okay. So in 35.2 gram of CO2 we have 0.8 mole, okay. So we have to find this delta H, okay, for this one, okay, for this 35.2 gram of CO2. So for 1 mole it is this one. Now for 0.8 mole, for 0.8 mole of CO2, this delta H, it will be minus this one, 39.5 kilojoule per mole into 0.8 mole, okay. So we just cancel this one. What we will get is minus 314.8 kilojoule, okay. Now let's take this one, the next question. Enthalpies of formation of CO2, N2O, N2O4 gas are 110, minus 110, minus 393, 81 and 9.7 kilojoule per mole respectively. Find the value of delta RH, okay. That means enthalpy of reaction, okay. The reaction is given, okay. So the formation of this one are all given here, okay. Their formation, okay. This formation of enthalpies of this CO2, N2O and N2O4 all are given, okay. So we have to find the enthalpy for this reaction, okay. So this enthalpy is given by delta RH, okay. So in this case what we have to find is the enthalpy of the reaction. So this delta RH is given by enthalpy of formation of product, okay. Okay, summation of enthalpy of formation of product by minus this enthalpy of formation of reactants, okay. So delta RH we can write it like this also, the enthalpy of formation of this one product, okay. Now we are going to write the product N2O plus this 3, okay. This coefficient also we have to add CO2. Now reactant, okay. Firstly this one, enthalpy of formation of N2O4 plus 3, so 3 moles. This coefficient we add, okay, 3. So this will be 0. Now in this case, what we are going to do is we are just going to put this value for N2O. It is 81, okay, 81, N2O 81. So we are just going to write 81 plus 3 into CO2. It's minus 393. Now for this one, N2O4 is given 9.7 plus 3 into CO is minus 110. So if you calculate, it will give you 1098 minus 320.3. So finally your answer will be minus 77.7 kilojoule per mole. Let's see the next one. 6.13 exercise. Given N2 gas react with this dihydrogen gas, 3 moles of dihydrogen gas, to give 2 moles of ammonia. So enthalpy of the reaction here is 92 minus 92.4 kilojoule per mole. What is the standard enthalpy of formation of NH3? So this standard enthalpy of formation, okay, it should be in 1 mole, okay. So the enthalpy change involving that 1 mole, okay, of this ammonia. So we have to convert this ammonia into 1 mole only, okay. So in order to convert this into 1 mole, okay, what we are going to do is we have to make it this 2 to change these two moles to 1, okay. So simply we can divide it by 2, okay. So we can write the chemical reaction of the formation of ammonia, okay. For 1 mole of ammonia, we can write it as half N2 plus 3/2, okay, so NH3, okay. This NH3 means these 2 cancel and we are getting 1, okay. Yes, so this delta H, it's here, minus 92.4 kilojoule per mole. So for this delta H, we have to divide it by 2 also, okay. Since we are converting it, we are dividing, okay, it by 2, okay. So delta formation of this one, okay, NH3 gas will be 92.4 kilojoule per mole divided by 2, so it will give you minus 46.2 kilojoule per mole.